Any questions anyone should go over after this? Guys, we're good on everything? Nolan, were you looking up a question or did you? 17? Let's do that. Anything else, guys? Oh, right. Oh, you read it, Ron? You got it? Anybody? Anything else, you guys? Great. Send one back. So if you guys can take a minute to look at the warm-up question. All right, so they tell us that we have a triangle with angle measures of 45 degrees and 92 degrees. So when I hear something like that, I feel like I need to draw a picture. Like it's hard for me to visualize stuff like this without actually drawing it. I like seeing the image. Now, if you don't need to, that's fine. So again, I'm going to draw this. And now I see the 92-degree angle, and hopefully that already jumps out at you. That makes you think of what in terms of our answer? Obtuse. So already, I can cross out the acute ones. So we talked about this a little bit with some test-taking strategy, that you're smart about kind of eliminating ones that just don't make sense in the problem. So I'm going to draw an obtuse triangle, where I know this has to be 92, and then 45. Now it asks us, is it obtuse and scalene or obtuse and isosceles? What does one of those tell us? Like, one of those gives us some really big clue. Anyone have an idea? So again, we're looking at these two. One of them kind of eliminates itself. Any thoughts? Yeah. How do you know that eliminates itself? Yeah. So isosceles, hopefully you look at that and say, oh, that means two sides are equal. I think that's more we think about sides. But that also means two angles are equal. Then how do we know we don't have two equal angles here? Yeah. Very. Yeah, so he was saying he knows knows that if it's 45, the other one has to be 90 in order to be isosceles, to be 45 and 45. If you did the math, you figure out this would have to be 43. So we don't have two equal angles. Now you maybe didn't even need to do that. You could just kind of like know that, but I wasn't sure if you guys were super comfortable with that, but we could eliminate that isosceles because it doesn't have two equal angles. So it's obtuse and scaling. And again, with a big test like an ACT, a multiple choice test, they try to have you use some of those strategies and show that you guys know a couple of things in this problem. So we're going to talk more about angle measures today and side lengths, and there is a relationship between those two. So kind of good news is we're not getting a whole bunch of new vocabulary today. So like the vocab chart we did, the purple one, is pretty much kind of it for vocabulary, I believe. There might be a few other facts we'll learn, but we're pretty good on vocab for this chapter. And those of you guys who are online, I did attach that vocab chart. I forgot it yesterday on the notes. So it is attached on yesterday's notes. So we're talking about, there is going to be a relationship between angles and sides in a triangle. So in terms of a triangle, I'm trying to think about what I can use other than my arms. Here. A closet full of yardsticks. So if these are sides of a triangle, and I'm working my sides of a triangle, these are two of my sides. Obviously, the third side would be over there. What happens as I make this angle bigger? What would happen to that third side? So if it's here, what happens when I make this angle bigger?
It's longer.
This side gets longer. So the bigger this angle is, the longer that side will be. So as that angle gets bigger, the distance between those gets longer. Seems like a pretty logical idea. Well, it's like an idea in math that we need to use. So if we have A being the largest angle, that means we can conclude that the side across from A is going to be the longest side. So that one directly across, we can conclude that BC is the longest side. So again, if angle A is the largest angle, then we can conclude that BC would be the longest side. And again, that seems logical, but it's a rule. It's not just like because it seems that way. And then if angle B is the smallest angle, so again, kind of the idea, why is this being so finicky this morning, sorry. So if angle B over here is the smallest angle, that means the side across from it is going to be the shortest side. So in example 2 there, I don't know why that's example 2, that should just be example 1. We want to list the angles and sides from smallest to largest. So they give us a triangle here, and they tell us some angles, and we want to list the angles and sides from smallest to largest. And when you name the angles, you can just use a single letter. So you don't have to use like CHS or something. You can just call it angle H and angle C. So I'll give you guys a minute to try that. visual that I'm making right now. All right, so which is the smallest angle? Which angle is the smallest? Angle S. How'd you figure out angle S is the smallest, first of all? Because right now they kind of all look the same size. What'd you do? How'd you figure out angle S was the smallest? What is the measure of angle S?
57.
57. You figured that out because they should add up to 180, right? So S plus 58 plus 65 should equal 180. So we find out angle S has to be 57 degrees. So angle S is actually the smallest, even though they kind of all look the same size. So we don't want to make any assumptions there. So angle S is the smallest, then hopefully H, and then C. Hopefully that wasn't an issue. But then the sides are dependent on those angles. So what's going to be the smallest side? CH. It's across from the 57 degree angle. Now I don't know how long CH is. I don't know if it's 5 units. I don't know if it's 55. I don't really know anything about it. But I know this is going to be the shortest side. So the shortest side is going to be CH. What's next? CS, very good. Because it's across from, so this is 1 shortest, 2 middle, 58. And then finally the only one left is SH. So you should be able to order sides and angles based off of what you guys know. So what I was doing here, my little craft project. Show you guys. So the next thing we're going to talk about is something that you definitely don't think about very often. So it's going to be something. So I have these 3 lengths of a triangle and they form a triangle. So that seems good. That forms a triangle. Everything's good. So we have 3 lengths. Obviously they're not all the same. I think the yellow and the purple are actually pretty close to being the same length, but the green one's obviously shorter. It forms a triangle. Now, what if I replace one of those sides with a much shorter side? So let's say I take out this purple one and put this pink one in. Can I make those into a triangle? Do those form a triangle, those 3 side lengths? No, it's not automatic that 3 side lengths have to form a triangle. So that's what we have to talk about here. So if I take these 2 and put them touching the end of this yellow one, there is no way to make this work. Like if I try to stretch them and they don't really stretch, so like for instance, if this was, let's say this is 8, and I don't know, that one looks about 4, this one looks about 2 or 3. They don't form a triangle. So my question to you guys is, what needs to be the case? Like what does pink have to be in order to form a triangle? Like what's the bare minimum for that to work? Because we had it work. Like if pink was a longer length, that worked. So when I had it like this, or I can make one like this, that one worked fine. That makes a triangle. So what do the qualifications need to be for those side lengths? This is called the triangle inequality. So there's like a rule that goes with this. All right, so Drake's got his hand up. What do you think?
Each side angles have to add together to equal or become more than their lengths.
Okay, and I'll change your angles to sides. Sides.
Yes.
Okay, yeah, I knew what you were saying. So he was saying the 2 shorter ones together either have to be the same length or longer than the third one. Yep. it does kind of sound like a squared plus b squared equals c squared. It's not going to quite be that. That we're actually going to use that idea tomorrow. We're not going to square them. We're just going to talk about side lengths. But you're right about a squared plus b squared equals c squared. Now I want to test Drake's theory here. Let me see here. So hang on, so he said the same length or longer. So this green one, these two parts are the same length as the yellow. Does that form a triangle? No, it's okay. That's why I wanted to show this. So what needs to be true about the two green ones? They need to be what? More than. So it can't be equal to, because if I walk into a kindergarten classroom and I say, hey, here's a triangle, the kindergartners would like laugh me out of there, right? Like they'd be like, no, that's not a triangle. We know that's not a triangle. So the two shorter sides have to be at least longer. So even if they're just a little bit longer, that'd be kind of a little flat triangle, but it needs to be longer. So that's what we're going to write down. So the two shorter sides need to be longer than the third side. And I like that you were willing to put it out there. So I mean, you're really super close. It's just that little piece of it. So kind of using this example, and I am going to use A, B, and C. I'm going to call this my C, my longest side, and then my A and B. So kind of in general, is that A and B need to be greater than C. So the two shorter sides together have to be bigger than the longest side. And I'll write that in like words as well. And this might be enough for you, but I have like a definition as well. So it says the sum, so that's the addition, the sum of the lengths of any two sides must be greater than the third side. So we're going to use that in a second here with some examples. I think we could probably take a break now. The sun went away, but do you guys want to go outside? So we're not any more nice days.
Yes.
Yeah, I go outside. Can we do like a parking lot walk? Yeah. Okay. Go outside and do that. But, so those of you guys online, we're going to take a little break. So I'm going to stop the video and start a new one later.